Hello students, welcome to the cbse chemistry lecture series. In the last video we discussed the coordination compounds and its important key terms like various parts present in the coordination compounds like central metal atom, ligands, coordination sphere, coordination number, oxidation state, counterions. Like that we discussed all these definitions. Now we are going to discuss about the IUPAC names. Say for example K4FeCN 6 times. So how to name this complex in a systematic manner for IUPAC names. The another one is a CuNH3 4 times SO4. Here I already told you the K4 is a counterions. Here in the second complex SO4 is a counterions, or you can say ionization sphere. The remaining other things, whatever present in the square bracket, that is normally ligands and the central metal atom will present the square bracket. We can call this coordination sphere. So while discussing this complex, the IUPAC names, so which should be the first, which should be the second? So that all we will see the rules and regulations how to name a coordination compound in a systematic manner. That is called IUPAC nomenclature. Yes, now we will see the rules and regulations for writing or naming a coordination compounds. The first rule is always cation first. What it means actually? Say for example, in this case, we will take one examples. K4FeCN 6 times. Here if you check the complex and the cations, this is a simple cation and this one is a complex anion. See, always cation first, that means you have to write potassium. Potassium is a cation. So that first we have to write as a potassium. If it is the next one is a naming of ligands. The naming of ligands is nothing but we are having already defined various types of ligands are there. What are the various types of ligands? Say for example, negative ligands. The negative ligands, if we see examples like what Cl minus, Cn minus, these are all negative ligands. So the name is having the special names who are ending with O suffix. Say for example, this is a chloro, or you can say chlorido. According to the IUPAC 2004 nomenclature recommendations, this only you have to use. Chlorido is the correct one. But in some textbooks they are using chloro, chlorido. Both are correct. But according to the 2004 IUPAC recommendations, chlorido is the correct one. And similarly, cyanide, you ought to say cyano. But nowadays you ought to use only cyanido is a correct exact one. So these are all negative ligands which have the suffix O sound. Suppose if it is some other ligands which are neutral and has some special names like what? NH3. Normally in other places in chemistry we have to say it's ammonia. But in this coordination compounds you have to say amine. It is a special name given to this NH3. Similarly for water, H2O, in this particular coordination chemistry we have to use aqua. Okay. And other special names for what? This one. En stands for ethylene diamine is a common name. Ethylene diamine is a common name, but we can also write ethane 1,2 diamine. This is according to the IUPAC nomenclature. This one is a ethane 1,2 diamine. Okay. And third rule is numerical prefix to indicate the number of ligands. In any complex, if we see that one ligand, say for example, in the previous example, cyanide is 6 times. So in that case, you have to how to denote a number of ligands. It is a 6 ligands. If it is a 2 ligands, then you have to use the prefix as a di. If it is a 3 times, then it is a tri. If it is a 4 times, then it is a tetra. If it is a 5 times, then it is a penta. If it is a 6 times, then it is a hexa. And so on. Suppose if the ligands having a di, tri in the name itself, say for example ethylene diamine, So here the ligand itself having the di, tri, tetra, then you have to use bis. 2 times means bis only you have to use. If it is a 3 times, then you have to say tris. Like that you have to go. If it is a 4 times, tetrakis. Just like that you have to numerical prefix to indicate the number of ligands. That is the third rule. Then the fourth one is the order of naming of ligands. In any complex, if more than one ligand is there, then you have to arrange the ligands in alphabetical order. Arrange the ligands in alphabetical order. Say for example, NH3 is there, Cl is there. So you have to arrange the ligands in alphabetical order. That is amine first, followed by chlorido. So because you have to see the alphabetical letter A, C, you have to arrange it in a sequence manner. That is the order of naming of ligands. Naming of complex and ending of central metal atom. Say for example, so I will give you the complex. The complex may be 2 different types. One is a cationic complex. Another one is an anionic complex. Or you can say non-ionic also this case. In these cases, if you have to observe it whether this complex is a cationic complex or non-ionic complex or anionic complex, and the name of the central metal atom, it should be in a different manner. How we have to use that one. Say for example, you can take this case. If it is a cationic complex, say for example, I will give one cationic complex Cu NH3 4 times SO4. So this is a anion. This complex is a cation. This complex is a cation. Then how can you say the central metal atom or ending of the central metal atom should be as such? What is the meaning of as such? Means the copper only you ought to say. Even if it is a non-ionic, I will give an example for non-ionic. What is it non-ionic? Nickel tetracarbonyl. So this is there is no charge on this complex. Here also you have to say as such. Nickel only you have to say. So this is the rules for what? Cationic or non-ionic complexes. At the same time, if you are having a anionic complex, say for example, K4 Fe Cn 6 times 4 minus is there. So this is an example for anionic complex. If the anionic complex you have observed means immediately the central metal atom should be in a Latin name. So the ion is an English word, Latin name is what? Ferrum, and that suffix you have to say ATE. So therefore this is what? Ferrate. So the ferrate, when you have to add this ATE means you have to think about if there is a anionic complex, then the name should be ending with the central metal atom. Name is ending with the suffix ATE. Okay, that's all these rules and regulations. We will take a few compounds and we will discuss the nomenclature, IUPAC nomenclature. Yes, we will take few compounds and write the IUPAC name in a systematic manner. Say for example, the first complex, cobalt is a central metal atom, NH3 is a ligand and it is a 6 times. Close the bracket, square bracket and Cl3. The Cl3 is a counter ion or you can say coordination or ionization pair, whereas the remaining is coordination pair. So how can you name this complex? You have to check whether this complex or ion is what type of things, whether it's a cationic complex or anionic complex. Yes, it's a cationic complex. So the central metal atom should be as such. And first you have to think about the ligands. What is the special name for these ligands? It's a amine. How many times are the number of times or number of ligands present this one? It's a 6 times. So you have to say hexaamine. So how can you name this compound? Hexaamine. S. Followed by the central metal atom. Is a cationic complex or anionic complex? This is a cationic complex. Here the charge is what? 3 minus. 1 Cl is 1 minus. So therefore Cl3 means 3 minus. This is what? 3 plus. So you have to say the central metal atom as such. So what is the central metal atom? Is cobalt. And what is its oxidation state? I already told you, it is a sum of the oxidation state of central metal and the ligands present, the number of, that's called coordination number. If you add these two things, we can get the charge of the complex. Charge of the complex is what? 3 plus. Here there is what? Amine is a neutral ligands, 6 into 0, 0 only. So we have to, the 3 is the oxidation state of the central metal atom. So here you have to say cobalt 3. And the counter ion you have to say as such as chloride. That's all. This is a correct IUPAC name for this complex. The second one, Cr is a chromium is a central metal atom, and En ethylene diamine is a ligand, is a didentate ligand. Okay, it's a didentate ligand, and Cl3. So in this case, how can you name these compounds? I already told you, if the ligand name itself is having a ethylene diamine. Di is what present, the name of the ligand itself. So in that case, you got to use, if it is a 3 times means you got to use tris. So tris ethane 1,2-diamine. Now here also you got to check whether it is a, what type of complex. It's a cationic complex. So you got to say tris bracket ethane hyphen 1,2 diamine, and this chromium as such, chromium 3 chloride. So I am putting a oxidation state is what? 3. Here it says neutral ligands, therefore this is 3 minus, this is also 3 plus, therefore it is a 3. That's why it's a 3 chloride. The next one is an example of non-ionic. Non-ionic central metal atom also as such you have to use it. Okay, so you got to take an examples. This is a carbonyl. How many times? 4 times. So you got to say tetracarbonyl. Tetracarbonyl. Nickel. Its oxidation state. Any metal, if it is bonded with the carbonyl atoms, its oxidation state is 0. That's all. This is a IUPAC name for this. Tetracarbonyl nickel 0. The next one, unfortunately, this also what? It's a non-ionic. So here we are having the ligands triphenyl phosphine and the carbonyl group. So you have to arrange the ligands in alphabetical order. Which should come first? Carbonyl. So it's a pentacarbonyl and triphenyl phosphine chromium 0, because it's also a non-ionic one. So we will take one example of what? Example of anionic complex. Say for that's the 5th one, K4 or K3 you can take Fe, Cn 6 times. So this case, this one is a, and so this is a K3 plus. This means automatically this is 3 minus. The Roman letter is 3. You got to always cation first, potassium. Arrange the ligands first. Only one kind of ligand is there. How many times? 6 times. So you have to say hexacyanido. Hexacyanido. And what is the central metal atom? It is anionic complex. Therefore, it has a suffix ate. Ferrate. And its oxidation state is 3. That's all. So this is the proper way of naming the complex in a systematic manner. So if you have any doubt, please mention in the comment box. Thank you, students.